and Chad.
Hey everyone, welcome to the session, and thanks for tuning in and giving us your time to talk about data and data quality in particular as it relates to ML. I'm Manu Bansal. I'm one of the founders of Light Up Data and also the CEO. We are a four-year-old company building data quality and making it super easy to apply data quality at the scale of enterprise, right? So in a scenario where you feel the need to drive your data operations with Databricks, you would be running into scale where data quality starts to become a challenge. And chances are you're starting to put data into the critical path of the business. That could be driving revenue, that could be driving key decisions, and in most cases, actually directly driving customer experience. And when you have data in such a critical kind of role in your machine learning models driving customer experience, whether it's pricing or whether it's telling someone when the ride will arrive or what the inventory looks like, you cannot afford to have bad data flowing through that pipeline, right? And that's a problem that we can solve really well. That's the mission that we have picked up as the life of this company. And so super excited to be talking to you today about data quality and why it's so critical to ML. And we decided to invite Chad and would like to just briefly introduce Chad and then let him introduce himself. Chad runs data platform at Convoy. And if you have been paying attention on LinkedIn, you would kind of agree with me that Chad has this extremely uncanny ability to present really hard data management concepts in a way that's super relatable. And I thought, what's better than to just have Chad express data quality as a need of the hour in his own words. And so we decided to pair up and talk to you about data today. And I'll just hand it over to Chad to introduce himself.
Thanks, Manu. Hey, everybody. Happy to be here. My name's Chad. I am the head of the data platform team at a company called Convoy. Convoy is a late stage freight technology startup that is at a pretty interesting place in its data journey. We're I wouldn't say a small business. We don't have small data, but certainly much smaller than the scale of like a Microsoft or LinkedIn or YouTube. We're working with billions of rows of data. And our problem is not necessarily as much on the compute and storage and sort of cost of all of this data, but what do we do with it? And how do we use it in a trustworthy way? Our data is extremely complicated and the data flows in nonlinear ways. So we need to be able to understand, what is our most important data? Where is it coming from? Who owns it? What is the quality of that data? And if it breaks or if something goes wrong, who is going to be impacted by it? These are extremely important things for Convoy to understand. And that's really the crux of what I hope we can talk about today.
Awesome. And you just kind of said there, Chad, that data is extremely complicated. I don't know a data leader that doesn't think that way. That's kind of the challenge and the excitement of what we do. We're always dealing with a lot of first off, very nuanced data models and whatnot, and trying to extract value out of this gnarly beast that data is, right? And what's interesting to me is even as we heard in the keynote today, right? Yes, we all want to drive new business opportunities with ML and AI, but at the end of the day, that just ends up being a data problem before anything else, right? And we're kind of hearing industry stalwarts, Professor Andrew Ng, for example, shift his tone from doing model-centric AI to starting to talk about data-centric AI and how everyone is kind of independently arriving at the same conclusion. So very interesting to talk about this topic today. But would like to kick off by kind of hearing your experience as a leader in the data space and building platforms and trying to put them to use. Now, what was your kind of come to Jesus moment? How did you come to realize the value of data quality? And I mean, were there some kind of hard occurrences where you paid the price and then it was like, yes, we need to be thinking about data quality before anything else?
Yeah, that's a great question. So before I ran the data team at Convoy, I worked at Microsoft on their artificial intelligence platform team. And I remember I was talking to a data scientist that worked with Bing, which was one of the largest consumers of machine learning and AI in all of Microsoft. And this data scientist had put together a small training set for a model that they were testing out internally. And they had found that someone else in the Bing organization was now taking a production dependency on this test data set that they had created and were no longer maintaining. And this person had their mind blown. They had no idea that anybody was even using that data. It was never intended to be like production quality. There was no maintenance over it. And yet here it was like being used and even presented by other people as delivering trustworthy results. So if that can happen in an organization like Bing, which has lots of governance and guardrails and everything else, I knew I was going to see some similar problems when I went to Convoy, and that's exactly what happened. At Convoy, you have really important key data sets, business objects that represent sort of core concepts within Convoy, like a shipments table or a tenders table or a table that represents all of our brokers. And before we started making a big push for data governance and data quality, a lot of that data was technically not owned. It was created as this early data infrastructure when the company was in its first 1 to 2 years of existence by one data engineer that did a lot of work and were super underwater because they were just trying to help the business answer as many questions as they possibly could super quickly. Then they kind of forgot about it and didn't really come back to it. Other teams took hard dependencies on that data set and then started adding on columns like as they basically saw fit. And the ownership of that data and its original use case became very, very murky. But those data sets still became sort of the cornerstone of all of our machine learning models. And when those started to break down, when this quality started to break down, that means that our models started to break down as well. And that was the point that we realized that we really needed to get a handle on quality, or else our entire machine learning and artificial intelligence investments would be, severely underutilized.
There's so much to unpack there. Right. I mean, and I think that's a story we can all relate to. I hear that all the time, and I'm sure we have all been in that situation. But before we kind of start to deconstruct that, right? Are there like these really embarrassing moments, any that come to mind? I'm sure there's some that are etched in memory, right? Where you said, this is going to potentially kill the business. And this is no longer a choice. This is no longer nice to have, right? I mean, this is visible all the way to the CEO or the C-suite, and it just needs to be fixed.
Yeah, definitely. So there's two pretty embarrassing moments that I can remember that stand out anytime I'm giving examples of how why we need to make the data quality investment for the sake of our machine learning initiatives. One was a little bit about Convoy, but we are actually a freight marketplace. That's our biggest differentiator between a traditional freight broker. So we sit in the middle of a shipper that's trying to find some carrier, which is a business that owns trucks to take freight, and then the carrier that is actually going to be taking that freight. We offer that freight through a marketplace, and we provide an auction model where the carriers can bid on freight, and it allows like really, really big corporate carriers to compete right alongside sort of smaller carriers that oftentimes don't get a piece of the pie. So we actually had a machine learning model that we built, which predicted how human beings in the marketplace were going to bid on shipments. And that was important information. We use this in a variety of different features. Sometimes we would use it to determine when we should actually be ending an auction. If we saw that the human bids were going to kind of start to taper off, and there's the time delta between when the auction ended and when the shipment actually needed to be delivered was quite small, then sometimes we would just make a call and say, hey, we don't think that we're going to get a lot more out of this auction, so let's just go ahead and end it. The other thing is we had features where we allowed we tried to give smart bids to the carrier, like basically gave them some indication of what they should be bidding. And we used the machine learning model to derive that functionality. And this worked totally fine until we happened to launch a feature elsewhere in our app by a totally different team. And that team, the feature of that team was another machine learning model that was making automatic bids on behalf of certain carriers that had signed up for a particular program. So these were not like human bidders. This was a system. It was an automated machine sort of making bids on shipments. And we forgot to extract, to essentially filter out those automated bids from the first model that was attempting to predict human bids. And we ended up getting a lot more automated bids flowing into that data set than human bids. And so our original model that was trying to predict human behavior eventually was just predicting the algorithm of our own feature that we built. So that was a pretty embarrassing situation. And then the second is sort of short and sweet. So I'll leave it simple, but our pricing model is really the core of all of our bidding mechanisms. It determines whether or not we even want to include a shipment as an opportunity in our marketplace. If we don't think we can get a good price for it, then we're probably just not going to include it. And that's basically what our pricing model was determining. And that pricing model was drawing from a lot of upstream data sources, like I mentioned, that were unowned, where the data was changing all the time, where the quality was relatively low. And due to nulls and other things, we ended up having to drop about 10% of the data that fed into that model. So as you can imagine, that's a huge amount of data to drop for one of our core machine learning models. So those are two like really relevant examples that I bring up frequently in Convoy.
And that 10% drop is still not actually that terrible if you ask me. We've heard stories where people would basically end up discarding all data from the last couple of months. And that's like your first canary experiment, and you realize all this data you thought you were collecting for the last 3 months wasn't there or wasn't usable, right? So you basically set back in time by that much time period. And the first one was very interesting. You're talking about this kind of feedback loop that got built in the system where it's starting to train on itself. Very tricky issue. Where it kind of reminds me of one of the issues that I dealt with building the last company. It was called Uhana. We were building a predictive analytics platform for telcos, and working with one of the largest telecom operators in Australia, working with one in the US. And they're both supposed to be feeding us the same data from the same underlying hardware infrastructure and the same vendor, right? And we are in the business of predicting how the network will behave, right? So if you, Chad, are walking in a downtown pocket and you're watching a YouTube video, our system could say, hey, you're going to walk into congestion, and then maybe pass that into your YouTube application, so the application could buffer up more of that video before you hit congestion, right? So kind of very real-time control that you could drive with it. Very, very impactful application, but really relied heavily on us making a good prediction on what capacity you are going to get out of the network. And then one fine day, this Australian telecom operator comes to us and tells us, hey, your system is being ridiculous. It's telling me I'm going to get a gigabit per second on my phone. And it's physically impossible. We don't have that much spectrum deployed. It just, physics doesn't allow it. And he said, yeah, that makes sense. This should not be happening. So why is the system predicting so? Because we don't see any issues on our side. All the machines are up and running. All the services are showing green on our IT dashboards and APM dashboards. So where is this issue? Turned out it was a data quality issue because the customer just on a whim decided to feed us data in bits per second going forward, which used to be kilobits per second. So now everything is off by a factor of 1,000. And so we should have been predicting a megabit per second, and now we are telling it, declaring it to be a gigabit per second. And it's like the silent issue where the data has just semantically changed, right? And it wasn't actually our fault in that case, but well, you're supposed to catch it, right? That's just how it goes. And so we said, okay, there has to be a way for us to catch those kinds of issues where data just starts to drift and starts to create, haphazard behavior in the model and its predictions. So that kind of issue showing up in different forms, left and right. Very interesting. I mean, so we see this with some other customers. We're working with Fortune 500 customers in retail, in food and beverage industry, and people would just not get their loyalty points awarded back to them because data is not coming in, or the personalization campaign is just all going haywire, right? And so you're losing digital dollars being spent on marketing, and the customer is frustrated with you showing them irrelevant ads, right? Or the products are getting mispriced in one currency in the airport store, and they're just priced perfectly fine in the other currency, and you're wondering why are the sales not working out here, right? So it's very interesting how far reaching some of that impact can be. Um, kind of switching gears into, what makes this problem hard? Why is it that we keep kind of going back to anecdotes and keep talking about why this is still an unsolved problem when we have so much infrastructure, so much tooling, so much wisdom on data monitoring, not particularly data monitoring, let's say, but monitoring maybe in the DevOps community and how we have done this for software and applications, right? Why is this so hard to lift and shift to data?
So there's a few problems that I've seen in the data world that I think that the software engineering world has a much better handle on. The biggest one is ownership, and ownership is kind of a tricky thing. In the case of a lot of machine learning models and sort of AI systems, they are leveraging data coming from upstream sources, production systems, and they're using that to your point. They're sort of inferring what the semantic meaning of that data actually is, and then they're training their models on it. But in many cases, the software engineers or the data producers that are generating that data are not aware of what's going on downstream. They don't know how that data is being used. It might be going through several sets of transformations. And even if it's not, they may not even be aware that it's being used in a machine learning model. And so when those upstream producers haven't taken accountability of that data for the purpose of machine learning, it leads to a lot of unusual things happening. Columns can get dropped. The internal logic of a column or property might get changed. There might be some semantic meaning that gets changed. Maybe the semantic meaning, the semantic understanding between the producer and the consumer is just fundamentally different. And the same problem applies, within whatever your data platform might be. Is people are creating tables that represent sort of these core business objects. Like I mentioned at Convoy, we have a table for all of our shippers. We have machine learning teams that sit far downstream that build out pricing models that just consume this shipper data. And so what happens when someone who owns this shippers table decides to make a change to the SQL, and they don't tell anyone, and they don't alert anybody that this is happening, and they don't tell them why the change is coming and how it semantically changes the data? A lot of that ownership and sort of miscommunication drives a huge amount of the quality concerns, in my opinion. And I think the other reason is one that you alluded to, is that monitoring on this stuff is actually really hard, because you're not necessarily looking for flat out errors or failures. You're looking for this semantic drift, like the meaning of something has changed over time because of some upstream change. With sort of traditional monitoring tools, that's really hard to figure out. And we certainly haven't completely figured that out at Convoy. So I would say those are two of the largest issues.
Yeah, it's very interesting how there's an interplay between kind of technology and process or people, if you will, right? Where the first step seems to be just kind of deciding who owns data quality and how should the producer or the custodian of data interact with the producer or with the consumer of data, right? And should there be some understanding between the two? And I mean, that's the starting point. If you don't even know what you are going to call good data versus bad data, how can you even begin to measure it and call out issues, right? So that's kind of the first step. And that's, I think that's something that that is quite a big open topic, if you ask me, in the industry, the way we are seeing it, right? I think people are still kind of engaged in a very healthy debate and trying to decide who should own it. And I think more and more what we're seeing is that there's starting to be this interface being defined where, whether you call it a data contract, we call it an SLA, we call it some kind of an agreement between two sides of the house. But I think the understanding we're getting at is the consumers of data can define what the semantics should be and what's considered healthy data. And then that has to be passed back to the platform team to implement as controls. They're supposed to deliver data that has a certain level of quality associated with it, right? And let's assume that shops like Convoy or other customers that are leading the charge on building this right kind of have figured out how to have this communication happen, right? And the next step then becomes, what's the system that lets you quickly implement those checks, right? I mean, the last thing you want is for this to become so much of a burden on the platform team that they just throw their hands up in the air and they're like, I'm done, right? I mean, the cost of discipline cannot be so high that people just you know, continue with anarchy, right? So it has to be like the tool has to facilitate. It's like what Git did to version control for software, right? It made it easy, right? I mean, our APM tools did to monitoring application endpoints, right? It was so easy that you would just start there instead of arriving there through a reactive process, right? That's kind of what we are seeing too, and that's our mission statement. And I think, Chad, you are doing a great job of kind of shaping our thinking on how this communication should happen, and then hopefully we are able to provide a solution that actually works if that understanding is developed within the organization, right? I know we are up on time here. There's so much more I would love to talk to you about, but maybe we should keep that for another session. This is a great conversation. And we have another session later in the day where we are demonstrating the Lightup tool and walking through some of the core primitives and abstractions around which we have designed the Lightup platform to monitor data quality and make it easy for people who understand data to work with people who can build out those checks and are masters of scale and masters of engineering data quality checks, right? And would love to show you how easy we can make this process. So dial in for the session later in the day. And I don't know how we want to do this. Sue or Kaylee, if you have time for questions, happy to take a couple of questions, or we can keep that for later.
Yeah, I think we'll, any Q&A we can put in the chat and we can definitely answer those at the end of the session if we have some extra time. But right now, I think we're going to go ahead and get started with the technical hands